Hello everybody, I'm going to show you how to work the worksheet. Before we start, let me just say let's everybody wave at Andrew, who's here taking his test. It's 6th hour on Friday. He can't wait for the weekend. You got tickets to the game?
No, I don't.
No? Oh, bummer. Alright, so now I'm going to do this, and here, I'll say hi too. Hi! So this is how to work these titration problems. If I can get it to focus. Okay. First thing we have to do is write down the equation. Okay, so we have sodium hydroxide plus hydrochloric acid is going to give sodium chloride plus water. Okay, what information is given to us? Well, first of all, it's balanced. We know that we have 40 milliliters of sodium hydroxide, and we want to know the molarity. Over here, we know that we have 50 liters, or 0.050 liters of hydrochloric acid, and we know that it is 0.2 molar. So, we need to figure out our mole ratio. Always start with what's given. Hydrochloric acid. Can I figure out how many moles I have given this information? Why, yes, I can. 0.050 liters times 0.2 molarity is going to give us I guess I should turn it on. 0.05 times 0.2 is 0.01 moles hydrochloric acid. 1-to-1 ratio. And then we multiply, or then we'll have 0.01 mole NaOH. Now we want to find molarity, so we have to take 0.01 mole divided by the molarity, which is 0.040 liters, 0.25 molarity. Alright, second one. Potassium hydroxide plus sulfuric acid. And we're going to need 2 of those. K2SO4 plus 2 waters. The information we have is we know we have 0.050 liters of potassium hydroxide and it's a 0.3 molarity. We know we're going to use 0.060 liters of sulfuric acid. We need to find the molarity. Again, we start with what's known, our potassium hydroxide. Right there. So, 0.050 liters times 0.3 moles per liter gives us 0.015 moles KOH. What's my ratio of KOH to sulfuric acid? 2-to-1. 2 moles KOH, 1 mole H2SO4. That's going to give me 0.0075 moles of sulfuric. I want molarity, so I have to divide by the number of moles I have, 0.060 liters, and that is going to give me 0.125 molarity. Alright. Anybody getting car sick from me moving the camera all over the place yet? Here's our next equation. So, what's our known information? 0.060 liters of sodium hydroxide and a molarity of 1.2. We know we have 0.040 liters of hydrofluoric. What's the molarity? Again, start with what's known. 0.060 liters times 1.2 molarity will give us 0.072 moles of sodium hydroxide. My ratio of sodium hydroxide to hydrofluoric acid is 1-to-1. and I had 0.040 liters, that will give me a molarity of 1.8. Next one, NaOH. We know we have 0.4, a molarity of 0.4 for the sodium hydroxide. We have 100 milliliters, so that's 0.1 liter of hydrochloric acid. That is 0.25 molarity. If we start with what we know, 0.100 liters molarity, we get 0.025 moles of hydrochloric acid. Ratio is 1 to 1. Now, the question is volume. So we have to go from moles to volume. If you look at your mole map, if we divide by the molarity, and the molarity was 0.4, we will get 6.25 liters. No, 0.625 liters, which is 62.5 milliliters. 0.0625 liters. Next one. So now that's balanced. We know we have 0.040 liters of a 0.1 molar phosphoric acid, and we have 0.150 liters of sodium hydroxide. Once again, start with what we know. That means the phosphoric acid, if we multiply 0.04 liters times 0.1 molarity, we get 0.004 moles of phosphoric acid. What's our ratio of phosphoric acid and sodium hydroxide? 1 to 3. 1 mole H3PO4, 3 moles Na3PO4. So we're going to get 0.004 times 3, .012, what am I doing? NaOH. And then I have to divide by the volume, 0.150, to get the molarity. It's a messy desk. Imagine that. Alright, 6. We've got vinegar. We need 2 here, and we need 2 here. Okay, what do we know? We know that we have 0.055 liters at 1.2 molarity of our vinegar, and our barium hydroxide is 0.67 molarity. So we need to figure out how many moles of vinegar we have. 0.055 liters times 1.2 moles per liter gives us 0.066 moles. Our ratio of acetic acid to barium hydroxide is a 2 to 1. And that gives us 0.33 moles barium hydroxide. And we want to know volume, so we have to divide by the molarity, which was 0.67, and that will give us 0.049 liters, which is 49 milliliters. Okay. We have 0.090 liters of calcium hydroxide, 0.25 molarity. Our hydrochloric acid, we have 0.100 liters. We want to know the molarity. Our ratio is 1 to 2. And we're going to get .045 moles hydrochloric acid divided by our volume, which was 0.100 liters, and that will give us 0.45 molarity. Okay, this is getting long, so I'm going to stop here and then we'll pick up where we left off for the last three.